Hello, Alex Cole here with BobCAD-CAM. So in this video, we're going to work on an impeller, and we're going to show some tool paths that people commonly struggle with. We're going to start by looking at the floor and how to machine the floor in between two of the vanes. I want to start by showing the way that I like to organize my files just to make things easier as we go through this process. Okay, so here's the entire part. I have a layer that has the CAD files. That's the entire model. I have a layer where I put surfaces just for the area that we're going to be working on. And then I have a layer that has the wireframe geometry for that area as well. So let's go ahead and start looking at the process that I use. You'll see in most of my videos, I recommend always working in a very sequential process to create 5-axis toolpaths because of the complexity and the sheer number of options that can affect the result. So the first step is to create the initial path. Don't worry about tilting the tool. Just get the pattern that is on the surfaces the way that we want the pattern to be. Then moving on from that, then we look at the tilting strategies and we try to get the tool tilted the way that it needs to be to cut the part. And then we follow that up with any gouge checking that's required. And then we start looking at the linking options and getting our clearance moves proper. So the first step in this, especially when working with an impeller and to keep the toolpath calculation times down, I typically will create a looser tolerance, and then I will only create a couple of passes on the floor so that we can see what the results are of those passes and get that get that good toolpath on there. And then later we can come in and we can tighten the tolerances and we can create additional passes. And what that does is it allows us to find all of the settings quickly. We don't have to wait a long time for toolpath calculation. And then once we have all the settings where they need to be, then we can add those additional passes and we can tighten down that tolerance and then let it calculate longer, and we only have to wait that longer amount of time that one time. Okay, so let's go ahead and start creating our feature for this part. As you can see, I've turned my my surfaces on, the visibility of my surfaces. And what we're going to do is we're going to start by creating a mill multi-axis feature, and we're going to select the surface morph between two curves option. On the tool page, I want to use a taper end mill for this. So I'm going to select a tapered end mill, and I'm going to come in and I'm going to change this taper angle to a 5 degree, which is what I want a narrower tool for this. So we're going to set that to a 5 degree, and then we'll go into the parameters. Now the first step in this process of programming this, we're going to go ahead and select our curves and then our drive surfaces. So let's go ahead and select the first curve here. Now the first curve, turn the surfaces on so you can see this radius that tracks on the left side of the floor. We're going to be machining the floor, but I want to pick the curve at the intersection of the floor and that radius, going all the way up the left side of the channel. Zoom in, make sure I select the right one, and I can click on chain and see that I've got my complete chain. And then the second curve is going to be on the opposite side of the channel. We're going to get the right edge of the floor, and we're going to select that going all the way up. Now as it gets up here, I'm going to have to zoom in because there's this little jog in the floor where that radius blends. And I can check my chain on that. That looks good. And now we'll select our actual drive surfaces, which is the floor itself. And okay. Now, again, the first stage of this is we need to select our geometry that we're going to use, but the first thing that we're focused on is the pattern that gets generated on the floor. Now, I can go ahead and create many passes across the floor. However, that's going to increase our toolpath calculation time as we're proving this out. And since we'll be recomputing several times, as I mentioned earlier, we're gonna limit this. So the method I like to use is determined by number of cuts, and I'm just going to set this to a value of 2. And so that's going to give us a cut on the far left and on the far right of our floor surfaces. And we're going to set the tolerance to 5/1000ths of an inch. And again, that's just to reduce the calculation time during this configuration stage. And then as we finish everything, we'll come back and we'll tighten that tolerance up, and we'll create many more passes so that we can actually machine that floor. So once with that set, we'll go ahead and compute, and we'll take a look at the result. So if we backplot the result here, I can see my tool is coming in, and we are gouging the wall of this part. That's okay. I'm most interested right now in the path itself along each edge of the floor. We do have path complete from bottom to top on the part, and everything looks good with the path. The next step will be worrying about tilting that tool so that the tool is angled properly to cut through here. Okay, so we'll go back into our feature. Excuse me. And on the parameters page, we will go to the tool axis control page, and we are going to use the be tilted relative to cutting direction. That's the default. But what I want to do is I want to tilt that tool to the side and see if tilting that tool to the side will actually work to keep the tool from running into any of those fins. So starting with a negative 30-degree tilt, that should tilt that tool to the right. And let's take a look and see what that has done to our toolpath. Now, looking down here at the bottom, I can definitely see that it changed our angles, including one of them going right through the wall. So let's backplot this and see what's happening there. Okay, so this tool is at the beginning, it's definitely running right into our part. And now it's starting to lay over on its side as it's moving along the bottom there. So not ideal, although we're not gouging nearly as bad as we were. Okay, but the area that I'm really concerned about is right in here, the floor starts to make a pretty abrupt transition. And when it does that, it's kicking this tool to the other side. And we can actually see now we're gouging on the other side of this slot, and that's not going to be good either. However, up at the top, we actually don't look too bad, and we're not gouging again there. So now let's see what the other part, like the cut going the other side, let's see how it does. So far it's looking okay, and we're not gouging there. However, as we continue through, let's see if we have any other gouges. Okay, so we start gouging. Now we're gouging a lot as we go through. So that's not quite working. And actually what happens is at the end of this path, it looks like we're gouging, kind of considerably the whole way up. So there is an option we can use that kind of helps with situations like that. We could definitely see there's a little jog there at the end. And we're gouging again. So we defined a 30-degree tilt angle in the negative direction. So let's look at on our tool axis control page. In this advanced dialog right here, we have an option for gradual side tilt angle change. And since we applied a negative 30-degree initial side tilt, Let's actually go and put a 30-degree tilt in there. And what this is going to do is, so this is a gradual application of a tilt angle over the duration of the toolpath. So at the beginning, it won't affect it at all. And by the end of the toolpath, it will have fully applied whatever angle we have entered into this field. So by starting with a negative 30-degree tilt angle, we're actually going to finish with a 0-degree tilt angle, because this option here, the gradual side tilt, is going to keep applying more and more tilt in the positive direction of 30 degrees. So at the end of the path, we actually shouldn't have any tilt at all. So let's compute this and see if this helped us at all with this path. I don't expect it's probably going to get everything, but it might help us a little bit more on that second cut. So the beginning, we're still gouging pretty bad. And then, okay, so we're working up. This actually isn't looking too bad. Now we're really gouging again. We kick over. We're still working our way up. Now we're gouging the other side pretty heavily. So that side, this first pass on the left is still gouging quite a bit. Let's look at the second pass and see what effect, because this is where we're really going to be seeing the effect of that change. So that's starting with a gouge. We can see that we have much more clearance angle here this time compared to the last. And as we get into this heavy transition, okay, so we're gouging some there. The tool's kicking around. We're actually only gouging just a little bit here now. So we have improved this area substantially. And then all the rest of the way up, I'm actually not seeing any gouges there anymore. So that's pretty good. So we did improve the tilting strategy by using that option. However, now we're going to move to our next step, and that's where we're going to actually use the gouge check. Now, could we have used the gouge check to get rid of the gouges that we were seeing? Possibly. But gouge check isn't really designed to completely eliminate all of the gouging. You always want to try to get your path to where just small little corrections need to be made. And the more refined your path is before you turn to a gouge check strategy, the better the result will be once you apply gouge checking. So here we're going to enable the first gouge check routine, and we're going to set this to tilt tool, and we're going to look at our parameters. And again, by default, this has got a 90-degree min and max tilt range, so that's giving the system 180 degrees of freedom to tilt that tool from side to side. Now that's a lot, and I don't recommend trying to let the system make that big of an adjustment. So I like to limit this down to something that's more realistic as to what I think we'll need. So in this case, let's try 30 degrees. And I'm going to apply this clearance angle. So this clearance angle is going to define from the surfaces that we're checking against what angle should the tool use to stay away from that. That way we're not running the tool right up against some other detail on our part. We want to have a little bit of clearance there. So we're going to set this to 3 degrees. Okay. And the system is by default using the drive surfaces, but our drive surfaces for this toolpath is the floor. And so that's not what we're gouging. We're gouging into those other fins. So we need to select some check surfaces to tell the system what it needs to check. And those check surfaces are going to be the walls of the two blades that run up through there. And that's what we are telling the system. If the tool runs into this, tilt the tool to correct it. You can tilt it plus or minus 30 degrees and apply a 3-degree clearance angle. So let's compute this and see what our results are. Okay, so at the beginning here, we still have a little gouge at the very beginning as the tool's coming in. And we're not gouging anything. Everything is looking good. All right. And we're gouging on this side. Okay. But I want you to notice we're gouging into the holder, not the tool. So let's go ahead and stop, and we'll go back to the parameters. And we'll go to that gouge checking page. Now by default, we only check against the flute and the shaft of the tool. What we're running into is the arbor and the holder. So we're going to enable those two options, and let's compute this again and see if it has a different effect. Okay, so we still have this initial gouge we're going to have to deal with right in here. Okay, and the tool's coming around. And here we get into that transition area. And the tool is tilting over, but we can see we have not hit with that holder again. And in fact, that holder is staying a nice distance away from the fins. Okay, so that path there actually did quite well. So let's continue and see what the other side looks like. So we're coming in, we're cutting around, everything's looking quite well. Okay, so all of the gouging has been eliminated except for at the very beginning here. So we need to determine why we're running into this problem at the very beginning. So let's see what we can do there. See what we can figure out. Okay, so we're trying to sort out this gouge that happens at the very beginning of our path here, where this tool plunges in, and we can see the tool at the very entry of this part. We're clipping with that tapered end mill. So what we've done is we've set up a gouge check routine that's going to tilt this tool, and in the parameters for that we've defined our tilting angles and so on, and a clearance angle to be applied to this gouge check strategy. Down here at the bottom, we have options for remaining collisions or clearances for tool parts and advanced options. So these are like just generic settings that are configured or applied to the path in general. So what I want to look at is the clearances for the parts. And right now this thing is using a cylindrical clearance. The problem is we're using a tapered end mill, so it's not going to use the correct diameter because you can't, either we would have to make these values big enough to actually encompass the taper of our tool, because it can only run off one diameter and it's going off that tip. So what we want to do here is we want to set an angular clearance value that will apply based on our tool, and this isn't necessarily going to be cylindric, so I'm going to add a 3-degree clearance angle to the toolpath in general, and we'll say okay and compute that, and let's see what result we get from there. So if I backplot this, my tool positions and it comes in, and now when it's coming in, it's actually not violating that wall like it previously was. And as I step through, we can see that tool is getting underway in that cut, and it runs through the path. So I'm going to just kind of walk this thing along and make sure that no other gouges are kind of discovered along the way, having made that change. And I can see that there's none on that cut. So now we'll come down and see how the next cut starts. So it plunges in, it's cutting around. Oop, keep jumping backwards. And as it comes through, let me step through this. I'm not sliding the slider too well there. And as it's coming around, we're staying clear of everything, and that tool is following through that channel quite nicely. Okay, so we have effectively created the two paths, one on each side now. Neither of those paths are gouging, so any of the paths that would be in between are actually going to be a blend, a blend between those. So this is when we can actually come back into our feature and set our number of cuts to something like 20 and go ahead and compute this and see what our toolpath looks like. So we can see now we've got all these passes are working through here. We've got a nice pattern on the floor, but our linking moves are definitely not ideal. So I'm going to turn the visibility on of the whole part. We can see they're running right through the part. That's not going to be good, and this is the last step that we have to finishing this up. So I'm going to go into the feature parameters and go to the linking page. And on the linking page, I'm going to go to our retracts option. We default to retracting to a plane, and right now it's set to 1 inch. And because where my machine setup is, this isn't going to work. So for an impeller type part like this, I like running a sphere. And for a part this size, a 4-inch radius sphere should suffice. So let's go ahead and turn that on and see what that does with our path. So now we can see that we're repositioning around the outside of the part in a spherical motion, and it's nice and clean. So we can backplot this now, and we can step through these, right, and see where we're at. Okay, so the tool's doing good there. If I press play on this guy, we speed it up a little bit, we'll see this tool work its way around. We're not gouging anything so far. Now the tool's going to reposition. And we're going to come in and make our next pass. And so this is going to machine across that entire floor and give us a nice, clean, uniform floor finish with all of these passes. Okay. So this is the method of programming and machining across the floor. This isn't the only method, but this is a method that I use probably most commonly. And it's a way of incrementally working through the process of creating that path, finding where the gouges are, correcting for those gouges, and getting a clean path in the end that gives you a nice cut on the floor of a complicated impeller like this.